Yes, so this is one of the three packages. So let's discuss about the first one, the starter package. Just before discussing about the starter package, just to mention that the developer package is just the additional function is something to help the people to make a bring up. So they make the bring up. They with this developer package, you can very easily recompile the device tree. You can change the configuration of the kernel. So you can do a lot of things. And when it's ready, you can put all the things inside the distribution package. Okay, so just coming back for the starter package. So the starter package, inside we have the result of the distribution package image. So the so-called OpenSTLinux Western image. So this is one of the images that is possible to be built by the distribution package. And in this image, we have a set of demo and a set of applications. So we can run easily different use cases that are visible here on the screen if you buy a discovery with a screen. Let's see how to install this. So here we are going to see how to set up this starter package, how to get the source, and how to burn the flash with this starter package. So the first important page, if you see on the website, you will see that we have some getting started very useful. From which you can select some boards that you have bought. So here today we are going to use a DK board. So you can select this one, and then after you can. So it explains how to start. So how to unpack the board, what you have inside your package when you buy a board, and then after how to populate and start the image that you want to run. On this page, you have different sections here. You see, we can install the tools. We can configure the terminal, the hyperterminal that will help you to communicate with the target board. And after, once you have installed the Cube programmer, you will download this and you can start after the board. So everything is explained in this page. So if we want to go more into the details here in the download page here, we have the link here to access to the board, to the firmware package. So let's start with this. So I go in this part, go there, and here I go in. I arrived on the website, ST website, where we have the starter package documentation. And here I'm going to get the zip file. So, okay, it starts to download here. So during this time, let's see what is the hardware more in detail, because it will take a small time to. So let's come back to the slide. So what do we have to set in this board? So on this board, we have a description here. If we go to this, this is very useful, this part, because you have the structure of the wiki. So there is a title, which is hardware, and you can get by all the hardware, you have description, And on this description, you have the boot switch, you have the LED, you have all the connector, all the explanation on the board. So here we have I just show you the boot switch, but there is different parts. If you go to the board now, so we see the board here, which is there. So we have the connection of the display, the camera connector. We have the HDMI connector. We have somewhere an eMMC, I think. I don't know why it is. Here we have the PMIC. Here we have the STM32 MP2. Here we have the boot switch, the SD card here. And the more important is the reset button here, and also the two connectors. So one is for the power and the ST-Link. Here it is a F3 MCU for the ST-Link. And here we have the USB 3 dual role data port connected to the MP2. So here I'm going to set my board with the two switch set to 00. This is important because this will tell to the ROM code that we are going to boot from the USB or the UART. You have other configuration. You can also boot from SD card or you can boot from eMMC. And you have a last development. So this is for development engineering mode. We call it development mode also. It's when you are using Cube IDE and you want to use to download your firmware inside the Cortex M33. So yes, this is the final configuration. So you have just two cables connected to the PC. So let's start to open the console. So for this, you need, I will use Terraterm. So we'll open two Terraterm windows because we have two virtual COM ports. And one is for the mass storage and one is for the console, the Linux console. So as we don't know, because the Windows never tell exactly what is what, we're going to open two console and we will normally, from this console, we are going to expect to see what the board is doing. So I just need to select the port, dial port. So by default, we are at this speed. The correct settings are already present. Okay. So the two ports now are open. Now we are going to open Cube Programmer. So Cube Programmer is this tool. So you see, you have here on the top right, we have how to connect. So you can connect by UART or by USB. So I will select USB. And then I will try to, so I set the cable on my PC, my board here. And I just need to connect. So it will, so here we are the Cube Programmer is in the DFU connection with the ROM code. So the ROM code is a code which is inside the Silicium and which is also the root of trust for the security. So it's immutable, you cannot change it. So here we are ready for the download. So now we need to go for to see where. So here we have done this. So we have pressed the reset. We are in connection. So let's see now the download, if the download is over. Takes download and I copy it here locally. And I will extract the package. Okay, and now we have the package. Inside the package, we have the name of the release, and we go here. We have the SOC, so MP2, and here we have the description. Okay, we will see after, but we have we have all the binaries that has been. So it's OpenSTLinux Western image. So we have different partition. And we have also the boot chain here, the feedback artifact. So if we go to now to QProgrammer, we are going to tell which binary, which artifact we want to fuse on the SD card. So for this, I go to the zip. I'm going to take so we have different possibilities. Today we are taking Opti. We cannot go too much in details here, but there is different possibilities. So we see that we have a flash layout. So flash layout will tell which partition to burn. So we have flash layout for eMMC. We have for and we see we have decay board and evaluation board. So here we are going to take for SD card because we would like to show on the SD card. So SD card and the decay board. So there is two flavors. So I'm going to take this one this morning. So it's a decay board and it's for SD card. So here we see all the things. I will come back just in a few minutes about this and this. And here we select the folder to access to the image, to the artifact. So we go at this point. And we can start the download. So just to show that what's going to happen, because when we are going to do this, we are going to run the programming service, which is inside U-boot. So we should have some log coming. I've got a failure error. What's going wrong? It's effective. Opti. SD card. Keyboard Western. Okay, so let's reconnect again. There is somewhere. Okay, I don't know what's going wrong. Okay, bon. What's the problem of what? instant. Okay, yes, now it's okay. Yes, I went through a hub, USB hub, and for some reason we have some problem with this USB hub. So if we look at the console here, we can see that we are downloading the partitions. So currently we are using the bootfs partition. Okay, so it will take some time. So I let the system like this, and I propose to continue on the slideshow with more detail. So we have seen that we have been using this interface, but we have also, as Lizette told you, we have also the command line interface, and we are exactly the same as we are doing here. We are giving what we call the TSV file and the port on which we are downloading the binaries. So what is this TSV file? So it's very interesting. We have two parts, actually. We have the red part and the blue part. The blue part is just a flash helper. So it is the flashing service, actually. So when we start from the reset, we are going to load inside the internal RAM and the DRAM the FIP, which contains the U-boot, which embeds the flashing service with kubeprogrammer. And once this is started, we will flash all these sections. So we have different partitions, which is explained in the wiki. So we have at the bottom, we have the first stage bootloader, which is there. So it's the low address are there. We have different parts, so we come back, but we have all the partitions there here. And if we want to go into the details, we have here with the boot chain. So we start from the ROM code. The ROM code is going to start the first stage bootloader, which will initialize the external RAM, and then will also install inside this external RAM the second stage bootloader, and the second stage bootloader will install the kernel, and the kernel will start the first process. So here we have the same in ST. So this is generic. This is for ST. So we have the ROM code. The ROM code is going to download from the flash inside the internal RAM the first stage bootloader TFA. TFA will install the FIP partition, and the FIP partition contains U-boot and contains also OPT and the TFA BL31. Once all this is installed, the monitor will start U-boot, and then U-boot will start to download from the flash the Linux kernel, which is in the bootfs partition. So here we have exactly what we see. So we have seen this in the TSV. So we have the first stage bootloader that is TFA. We have two versions because it's for redundancy, for security, because when your flash is getting older, you can have some issues. So the ROM code we have a backup. This can be updated. This cannot be updated because here you have two FIP partitions, so you can have two versions of FIP using the over-the-air update. And you could also have different versions of all these partitions, A and B, in your flash if you want to make an over-the-air update. So here we have we have the first stage bootloader. We have then after the FIP, which is U-boot and OPT. And then after we have the bootfs with the kernel. So the bootfs contains the kernel, and the kernel after will attach all these file system, mount all these file system to be visible from the user space. So let's see now. We have started the board. So I'm going to change back my my connector because normally it has been finished. Let's check. Download each of us. No, it's not completely finished. But I have another SDMMC, and I propose to stop here because it will take time, and also it takes time at the first boot because the SD card partition are resized a little bit. So it takes time to resize the board at the first boot, the resize of the partition. So here we stop. I propose to stop the connection by exiting from CubeIDE. I have another SD card on my desk. So I just change the SD card. The one that I've done before. And I just change the boot switch to SD card. And you see now it's starting. So we get the log of U-boot before we have the TFA which is at the beginning. Yeah. So we are already starting. And then after the TFA is going to load the FIP. Then after we have Opti that start to be initialized. Opti will initialize all the secure peripheral. And then after we have U-boot which is starting, and then after the kernel. And if we look at the partition that we have seen this morning, just before, we see that here we can see the SD card with the two. So if I come here, we have the two mapping for the SDK. So here we see the partition of the TSV that are also explained here. We can see them here exactly. We have the metadata, the FIP, U-boot, the vendor FS, and the user FS. And if we look at the partition of the eMMC, we have this also. So we have user FS, root FS, but as you can see, we don't see the FIP. The FSBLA is not present because there are special partitions, which are the boot partition of the eMMC. So here we have this.